You're going to be asked as part of the course materials to go back and forth between flowcharts and pseudocode. Both flowcharts and pseudocode do the exact same thing. They tell you, without all the formality of code, what the code is doing. They take some shortcuts to give you a representation of the code without having to understand every last detail. So what they both should be doing is using variables from your data dictionary to solve the problem. They shouldn't be so English driven that you can't figure out where data is moving around the system. But that being said, everything else structurally is pretty much identical between the two of them. Just one's a more visual way of saying it, the other one's a more detailed text way of saying it. And so one of the tricks is picking which one you think better to do design in. Some people think better in flowcharts. Some people think better in pseudocode. Neither one of those is fine, but you're being asked to represent both of them. So how do I go back and forth? Well, here's a very simple example going back and forth. So on the left-hand side, we see a set of flowchart steps, 3 steps. We create a variable, we do some math and assign a variable, and then we return the answer from a variable. So on the right-hand side, you can see we have 3 steps. So we have the definition of a function here. So again, a little bit more detail, a little bit more granularity in the pseudocode. But I have a step to create a variable, a step to do some math and assign a variable, and a step to return it. So as you move from one to the other, the key thing is each line of pseudocode essentially becomes one line over here in the flowchart, and the arrows are flowing top to bottom as far as pseudocode goes. Each line goes one after the other, and so you can see the order that goes inside of here. Now, this is a ridiculously simple example. Should be fairly transparent to see this, but one of the keys inside here is notice the text inside of the box, the text inside of pseudocode is essentially the same thing. In this case, it's literally exactly the same thing. In this case, it's literally exactly the same thing. And this guy up here, it's the same thing. It doesn't have to be, but it does help. And there's not a lot of reason not to do that, just to keep it simple. Let's look at one slightly more involved one. Here, this one, not terribly involved, but it has an if statement as part of it. And so you can see we'll go backwards this time. I have a variable here, and I'm showing the variable getting initialized. And I have another variable here, again, being initialized. And then I have a decision. So if purchase amount there, and then I'm nesting my decision here instead of my pseudocode here. Anytime you have an if statement or a loop, I want to nest that inside of it here. So inside of my function, I nest everything. I give some white space to say this is all part of this function. As part of this if statement, I'm nesting it. This nesting in the pseudocode is reflected in the different paths we can see over here in the flowchart. And so here's my if statement, and then I'm returning the value down below. So for the most part, again, each line, I create a variable here. I have a box here. I create a variable here. I have a box that creates a variable here. In this case, you can see I've shortened the text. I have a little bit more detail. I'm telling you the type. I'm telling you what I'm doing. Over here, I'm just creating the variable. Both of them are acceptable. The flowchart, I get what I'm doing right there. The pseudocode, I give you a little bit more detail about what I'm doing there, and I could include it or not in the flowchart. Once I get to the if statement, then ifs and loops and case and switch statements become diamonds, and that's key. I need a diamond over here to represent that decision and then the branching that can happen associated with that. And so the stuff that's happening inside the true goes to the true branch over here, and then the false branch has nothing, so it continues straight down, and then the true branch also continues straight down to this line after the end if. Now the end if is not required. In code, you'll mostly see curly brackets here, but I think in pseudocode it adds a lot to be able to let you see your structures, let you know that this is done. And so over here, again, the really nice thing about flowcharts is it's very easy to see the branching. It's very easy to see the paths. If I do pseudocode well, I can see that there is some branching there, not necessarily follow each branch to its logical conclusion as easily, but I can once I get some experience. The key, though, remember, is that every box in a flowchart represents a line over here in pseudocode and vice versa. Every line represents a box in the flowchart. There are some exceptions to that. Sometimes I'll combine things. I'll do a declaration and an assignment together where I might do it in 2 separate lines or 2 separate boxes. But really that's just a little bit of stylistic difference. If you stick to the one-to-one rule, you'll do well translating between the two of these. And remember, they are the same logic. They are the same solution. And so there shouldn't be any need to do them differently. But it's important to understand how to represent each format the solution you're trying to present. All right. So best of luck and have fun moving back and forth.